Hey, so I did this little robot frog project. It's a frog that he drives around. You can control it via this IR remote, and it has some range sensors on it to check if there's a wall in front of him so he can avoid it.
As a baseline for this project, I've used Artful Bytes playlist on how to make a Sumo robot, but where I had to make changes to his project code is basically where the interesting part happens. For example, I had to re-implement how the IR signals get captured and how the PWM signals get generated. This is because while he does a board bring up, I wanted to just stick to my development board for this project, but this development board only has 20 pins and not all timers and all channels of these timers get exposed on this board, so I had to make do with what I had. So the MSP430 has two timers, TA0 and TA1, with 3 capture compare channels. But here's the problem: my launchpad board does not expose all of these channels, and I really needed them to generate a PWM signal for the left motor, another timer to generate the PWM signal for the right motor, and then one to capture the signals from the IR remote. And here's the solution I came up with. I'm using one of the timers just normally in up mode to generate the PWM signal for the left motor. That means I can use 2 channels to control the period and the duty cycle of my PWM signal to control my DC motor however I want. Now the problem is I only have 2 channels left on the other timer, which I somehow need to use to both control the PWM signal for the right motor and to capture the IR signals. Up mode would not work in this case because it would conflict with the IR signal, since, for example, up mode triggers an interrupt only every few microseconds. I needed to have a timer that could capture milliseconds for the IR signal. So I needed to put the timer in continuous mode so it could capture IR signals in input capture mode whenever they would arrive. Continuous mode means the timer would just count up continuously until it would overflow, then it resets and just keeps counting up. But while it keeps counting up, I can trigger an interrupt by using one of the capture compare registers by writing a certain number in it. That means I can now use one of the 2 remaining capture compare channels to capture my IR remote signals, while I can use the other one now to generate my PWM signal and manually adjust the timing and the period and the duty cycle. So basically now I can just write a number into this capture compare register, which will trigger an interrupt once the timer reaches that number. In this interrupt service routine, I'm turning one of the GPIO pins on and off for the PWM signal, while also writing a new number into this capture compare register that advances the timer by a certain period and adjusting for the duty cycle. I can basically manually get whatever PWM signal I want. So this approach worked for my few pins that I had, but I faced one last problem. After I've integrated my range sensors into the project, suddenly on my oscilloscope I saw how the PWM signal that I manually created got heavily distorted, which made my DC motor jitter a bit. And so the problem was my own PWM signal relied heavily on the interrupt firing at precise timings, but with the added I2C interrupts from the range sensors, there was a lot more interrupt latency introduced. I was able to fix the problem though by lowering the frequency of my PWM signal. The only downside to this approach was the lower frequency meant that my DC motors would generate a little bit more noise than they had to. So yeah, that was the most challenging and interesting problem I faced on this project.